So today we're going to talk about Ruby classes. Right? What's going on here? Talk about Ruby classes. Right? We said that Ruby is an object-oriented language, and we talk about object-oriented languages. What we're really talking about are class-based languages. Right? That's usually how we see object-oriented languages described. So far we've seen how Ruby tracks information, right, that we often call data, right, via variables. We've also seen how Ruby can implement behaviors in methods. For instance, we can keep information about a person, like their name, which we know is a string, and their test score, like an integer, like this, right? We say name is Gavin, and test score is 42. We've often seen that a method that returns a description that combines name and score, right? So we can have a method called description that takes a person name and a person score and returns a new string that combines those into a nice sentence for us, right? The person named whatever the person name is, scored whatever they scored. So if I say name equals Gavin, test score equals 42, print the description given name and test score, what my program will output should be, I put this into IRB, right? The person named Gavin scored 42. But if we look at this code, there's nothing that kind of organizes the description method and the variables. They're kind of independent things on their own, right? There's nothing that's organized them or grouped them, right? The information and the behavior aren't combined into a single representation, right? We're kind of talking about a person here, right? That has a name and a test score and some description. In order to associate the variables and the behavior to a single concept, maybe we would call this a person, we need this idea of a class. Classes combine data that are like values or variables and behaviors, methods, into one concept. Objects are nothing more than data and behavior together, right? So if anybody ever asks you, like, what's so great about object-oriented languages? It's that they combine data and behavior into one concept, an object. That's all an object is. It's all a class is. Data about something and the behavior of that thing, right? We saw that in React, right? State and rendering go together. The state of a component and the rendering of the component are what makes that thing look the way it does on the browser. The state would be the data, the render method is the behavior, and they go together. And so we've seen this already a little bit when we talked about React. Right? Objects and classes, data and behavior. It's like the number one thing to remember about object-oriented. If you remember nothing else about object-oriented, it's that data and behavior go together. That's what makes object-orientedness.
So that's what the class is designating.
Mm-hmm.
It's like what you were saying about how we had classes in React.
Mm-hmm.
Similar to that.
Yeah, they're exactly the same.
Okay.
The class part that was added to JavaScript that React is using, like the class part is not coming from React, that's coming from JavaScript. React just uses that style.
Okay.
Right? Classes were added to JavaScript because they were kind of missing. People think in object ways. JavaScript was like, cool, we can add classes and to our JavaScript language that didn't have them before, so you can think in an object-oriented way. Right?
Cool.
You can think about classes as a template that describes what data and what behavior we have. Right? You can think of classes as a template or a factory or as cookie cutters. Right? Classes are like cookie cutters and objects are the cookies. Right? An object is an instance of a class. So classes describe generally how a thing works. Objects are the things themselves. Right? So you can think of, like, in a cookie cutter, right, you might have star-shaped cookies, you might have Christmas tree-shaped cookies, round cookies, square cookies, right? So when you use that cookie cutter, you're saying, hey, this is the kind of cookie I'm making. Each of those objects that come out might be a little different, right? You might make a Christmas tree cookie that's green. You might create a Christmas tree cookie that's red, right? The green or the red is the data part of that cookie. Oh, you made a Christmas tree cookie? What kind of Christmas tree cookie, right? We've already created many objects just using the literal form of creating them. Name equals Gavin, right? We said before, right? What kind of variable is name? What kind of thing is inside of name?
String?
Yeah, it's a string, right? The string Gavin. If we were really doing this just to prove that it's an object, it is a kind of string. This is how we make objects in Ruby. So we've been using objects and classes, we just didn't know we were, right? Every number, when I said everything in Ruby is an object, everything in Ruby has a class. We can ask name, the name variable, what class are you? Oh, I am a string. What do you think this is going to return? I'll get to your question. What do you think this is going to return? Take a guess.
Number?
Number.
Yeah.
Yeah.
Integer.
We just call it integer. Right? In Ruby, we call this an integer. This is a floating point number, right? It's a little bit different than an integer because it has a decimal place. Right? We're going to come back to this discussion at the end of lecture, the difference between integer and float and number, right? So every variable, since everything in Ruby is an object, every object has a class. What kind of object are you? Are you a string? Are you an integer? Are you a float? Right? These are all the ones that are built in. Tatiana, you had a question.
Just so I don't have to waste time,
Mhm.
could you send the link?
It's always in the lecture notes on the next day, but I will put this in Slack.
Thank you.
Can you use fraction or like score equal like fraction?
I'm not sure I
Sounds
understand.
weird, but
Can I do what?
fraction like 4/5.
This?
Yeah.
Mm-hmm.
Oh.
It's just division, right? Score equals 12 times 4 minus 9 times 12 divided by 3. Mm-hmm. Yep, just like JavaScript. These are exactly the same. Right. That part's just math. What's going on? It says I couldn't send the...
Yeah, it did go through.
Did it go through now?
No.
Come on, Slack.
Do you need to refresh like
Oh. My Wi-Fi is not working.
yeah, sometimes we just go through and refresh the DNS
No,
or something, whatever.
no, it's not DNS because I have no connectivity.
What's the phrase we use to
It came through.
get to console log on terminal?
Console IRB kind of thing?
Are you asking how do I get into the interactive Ruby?
IRB,
Yeah, yeah. So it's not the console log. This is the interactive Ruby.
Interactive.
Yeah. The equivalent of console log in Ruby is called puts, right? The console, the Google DevTools console is to IRB as JavaScript is to Ruby, right? So when you do inspect console, that's IRB. Console.log is like puts in Ruby. Yeah. So we can make our own classes, right? It would be so boring if Ruby only had integers and strings and whatnot, right? That'd be awesome, but it'd be boring, right? What a language we could have that could have all these objects and classes, but we can't really do anything. So let's make our own class. Let's make a class called dog, and we declare classes like this. Right? We say class and the name of the class. There's going to be some code in between and an end. Class dog end. Notice that the name of the class is what?
Oh,
Capitalized. All classes in Ruby start with a capital letter, always and forever. So for class names, we use Pascal case. So for class names, we use Pascal case like this, right? If we had French dogs, it would be like this. Class names are Pascal case. At a minimum, they have to start with a capital letter. That's the rule for Ruby class names. They always start with a capital letter. So once I have this class declared, right, there's a new class called dog, Ruby now knows about another kind of object, and I can make one. This is how we make objects from our classes. Riley is an object that was created from the dog class. Instantiated. It is an instance of a dog. Right? Riley's the name of my dog. What kind of object is Riley? It's a dog. Just like this version of Riley is a string. Just like Gavin is a string, the Riley variable has inside of it a dog.
Wait, what's that? Oh, 0x.
Yeah, we're going to get to that. That's literally the next thing we're going to talk about. So when I say name equals Gavin, Ruby knows how to print that out. It knows what a string is and how to print it. When I ask for Riley, I haven't taught Ruby how to print what a dog is. So what it decides to print is the name of the class and where in memory it lives.
That's the hash.
Kind of. It's more like an identifier
Okay.
of the dog. Because if I make a new dog called Roscoe, notice that Roscoe's identifier is different. It's just saying that those are two different dogs, right? Just where does that dog live inside of Ruby's memory? What dog is it?
You can use hash and equal and arrow and like one, something like that, right? Hash
What?
equal arrow one. Arrow one. Yeah, can you use like that?
No.
No.
I'm not sure what you're asking.
It's
But-
right here.
That's a comment. Are you reading down here?
Yeah.
That's a comment.
Oh.
You're reading ahead.
Okay.
You're reading ahead.
Sorry, I was confused.
Yeah, you're reading ahead and that's confusing you.
Okay. Yes.
That's a comment. Anything like that that's a comment. We're going to get there. Hold on. So if this is a dog like Riley, right? I want to be able to give Riley some behavior. I want to be able to ask my dog questions and get answers. Right? So let's define the dog class a little bit differently. You'll notice now that my class dog has methods inside. Right? So we defined the methods yesterday, but now this method age is defined inside of the class. Right? If I ask Ruby age, what do you think this is going to return?
No.
If I say age,
It's gonna return 1.
so 1, anybody else have another guess?
No.
Error, null, nil.
Nil.
It's going to say error.
That's right, because you didn't say dog by age.
Right. This age method isn't generally available. This age method is only available for things that are dogs. I can't just call age. I have to say which dog's age am I talking about. Let's make a new dog. Here's Riley. I can ask Riley age 1. That's that hash 1. It's just a comment. I'm just trying to show you what the output would be, right? If I ask Riley for its age, I get 1. Let's make Roscoe again. That's my girlfriend's parents' dog. If I ask Roscoe what its age is, it also returns 1. Why? Because we've only defined one thing for the dog's age. Right? That's the only thing a dog can do. When I ask any particular dog what the age is, it's always going to return 1. Because we made the behavior the same. If you ask any instance of a dog, what is your age? It's going to return 1. Right? So cool. But what if we had 2 dogs with different ages? Same behavior, different data. Right? Same kind of thing. We're both talking about dogs, but dogs have different ages, right? Roscoe is older than Riley. So we have to provide data to the object. We have to, when I create the dog, I have to tell it how old it is. So when I ask it, how old are you? It can give me that information back. So the way we do that is with a special method called initialize. This is similar to the constructor in JavaScript. It's the initialize method that gets run when we instantiate a new dog. So what I'm saying is every time I make a new dog, I must give it one argument that is an age. And the very first thing I'm going to do is assign that age to a new kind of variable we haven't seen yet. Notice that this variable on the left-hand side is a little different. What's different about it?
There's an ampersand.
Yeah, it has this symbol in front, right? There's this @ symbol in front of it. This is a special kind of variable. It's called an instance variable. In JavaScript, this would be this.age. This age variable on the left-hand side that has the @ symbol says, this is the age for the specific dog we are working with. The age over here is the argument. So we're saying the age that you gave me, I'm going to store in my dog's memory and call it @age. Then when you ask me for the age, I can return my dog's age. Right? The instance variables are like little memory holes that every instance of an object has. So let's create our dog class again. Now let's make Riley. I don't know, Riley's like 3 now. Now notice this dog output is a little bit different. What's different now than the last time we saw this funny dog number?
Has age.
Yeah, it's got the @age equals 3, right? That's like the object's little memory, right? Every dog object has its own memory. If I make Roscoe is a new dog and I say 7, what's Roscoe's memory hole age? 7. So both of these objects have the same behaviors, but they can have different data.
So it just knows like, okay, I see what you're doing. All right, so it's like dog, and then it's identifying. You said that the initialize is like a method on it. Is that so? It's just
This is kind of like the initialize right here. This is me calling the initialize. We call new to cookie cutter stamp out a new dog. Right?
Right.
And when I stamp out that new dog, before I didn't give it anything, I gave it nothing. But now I'm giving it a 3. That 3 goes in right here. And then that 3 is copied into that dog's memory as @age.
So is there any way to I mean, I'm sure, but it's like, what if we wanted more other character, like defining characters?
We're getting there.
All
We're
right.
totally going there. You got it. That's good. That's good. When you start thinking these questions, that means you're picking it up because you're asking the next questions.
And then if we were to put that in the terminal and then just put dogs that knew, but we didn't put like an age,
Yep.
is it gonna give us something else?
It's going to give us an error.
An error?
It's going to say argument error, wrong number of arguments. You gave me 0. I expected to get 1.
Gotcha.
I expected to get 1 because we said, hey, every time you make a new dog, how many arguments are we expecting? 1. Right? As soon as you say initialize parentheses age, you're telling it every time you make a new dog, you must give me 1 argument that is how old that dog is. So now if I ask Riley age, I get 3. And if I ask for Roscoe age, I get 7. Right? Same behavior, different data. Right? That's what makes objects powerful. The same code, right, works differently if I say Riley age than if I say Roscoe age, because I told Riley to remember your age is 3, and I told Roscoe to remember your age is 7. Right? So when I ask this age, I get back 3 for Riley, but I get back 7 for Roscoe. Right? So this whole thing is repetitive. So Rubyists don't like repeating a lot of things. Right? You see the repetition here, def age, return age, right? If we added more attributes, color and sound, I'd have to have def sound, return at sound, def color, return at color. Ruby gives us a shortcut for these kinds of attributes. We get a method called attr_accessor. If we say attr_accessor age, sound, and color, what we're teaching Ruby is there's going to be an @age and an age method. There's going to be an @sound and a sound method. There's going to be there's an @color and a color method. Right? So let's make this our dog class. So you'll notice now that my initializer takes how many arguments?
3.
3. Age, sound, and color. And whatever you give me in age, I'm going to store an @age. Whatever you give me in sound, I'm going to store an @sound. Whatever I store in color, I'm going to store an @color.
The attr_accessors. So that's necessary when establishing multiple.
Even with 1, it's helpful. Because
Okay.
you'll notice that I did not write def age, def sound, def
Right.
color. Watch. If I make a new Riley, the very first argument is going to be how old she is. The next one is what sound she makes. She goes, aroo. And she is a piebald colored dog. Oops, the other way around, Gavin. Riley is a dog, not dog is Riley. Aha! So look at Riley's little memory instance variables. Age is 3, sound is aroo, color is piebald. I can now say Riley.age, and I get back the 3. But I did not write def age like I did before, because attr_accessor wrote that code for me. Right? Attr_accessor wrote an age method for me that gives me back Riley's age. Attr_accessor was like a magic programmer. It was sitting with me and automatically wrote that age method. It also automatically wrote me a sound method and a color method. It also wrote me a way to change Riley's age. So Riley got a little bit older. Now her age is 4. So attr_accessor allows me to say any dog's age, sound, and color. I can ask for it, and I can change it. So now if I look at Riley's memory, oh, her age is 4. because this line of code here changed Riley's age. I can do that because I have this adder accessor that says any dog, I can get or set the age, I can get or set the sound, I can get or set the color. That makes sense?
So the initialize and the accessor, it comes always together?
Not always, but usually. Not always, because there will be times when you have these without the initializer. I think we look at that, right? We can do this again. If I do this and I just say adder accessor, age, sound, and color, I'm going to leave the initializer out. So now, if I make a new dog, I can't give it any initializer, right? I did not give it an initialize method, so I can't put anything here. I can only put something after the new if I have an initialize method. So now when I make a new Riley, Riley doesn't know her age, sound, or her color. But I can still change Riley's age, and now she knows her age. I can still change her sound, and now she knows her age and her sound. Oh, she's not like, she's piebald. And I can change her color, and now she knows her age, sound, and color. So without an initializer, I have to make a new dog and then set her age, set her sound, and set her color. That's what the initializer helps do, is it does that all at once. So here's an example with adder accessor without an initializer. Right? I can't do Roscoe equals dog.new, he's 7, he goes woof, and he's brown. Ruby won't let me do this because I don't have an initializer. You gave me 3 arguments, but there's 0 initializers. Okay? In this case, I have to say Roscoe.new, Roscoe age equals 7, Roscoe sound equals woof, Roscoe color equals brown. Right? That's what the initializer helps me do. If I want to give a new object information the moment I create it, I use an initializer. If I don't care and I want to set it later, I don't use an initializer. Depends on what kind of setup you're doing, right? Sometimes they go together and sometimes they're apart. Right? Let's give, something is missing from this. Oh no, this is good, right? Let's talk about inheritance. You've seen inheritance already. Do you remember where you saw it?
JavaScript, CSS.
JavaScript. What part of JavaScript did you all use inheritance?
Object.
Yeah, it's a parent and child. When did you use parent and child stuff? In JavaScript time.
Man.
It's a method from parents to
Yeah. But you used it in a very specific kind of thing that you did in Wake 3.
Oh.
The first time that you learned the framework, what framework did you all learn? React,
Yeah.
right?
Jeez.
Class app something component extends. Class octocat extends component. That's inheritance. We're saying that our octocat is a kind of React component. Inheritance is having a child class that inherits all the behavior of its parent, right? We humans inherit things from our parents: hair color, eye color, diseases, unfortunately, etc. Classes are very similar. They gain all the data and behavior from the parent, but can extend that with new data and behavior. So for instance, in Ruby, we have the same syntax. Class good dog extends dog. The arrow here, the less than, is the equivalent of extends from JavaScript. Class GoodDog is a kind of dog. So if we do this, we now tell IRB, Ruby, hey, there's a new kind of dog in town. It's a good dog. Right? It has everything that a dog can do, plus it knows what its toys are. So if I make a goody dog is a dog.new, I can set its age, I can set its sound, I can set its color, right? And I can ask a goody dog, what are your toys? What did I do? Oh, not a... oh, shoot. I meant to make this a goody dog. A good dog. There we go. Now let's make the goody dog age 10 and its color black and its sound woof. And then I'm going to ask the goody dog what its toys are, right? There we go. Because a goody dog knows its toys, right? So anything that's a good dog has age, sound, and color from the dog class, but it also has toys from the good dog, right? So goody dog, age, goody dog, toys, Riley age, Riley.toys, nope. Because the dog class parent doesn't know anything about toys. Only the good dog child class knows about toys. So the good dog has all of the data and behavior of its parent, plus whatever we teach that class about. Right? It's a superset. It has more capabilities than a regular dog.
So when you say goody equals good dog.new,
Mhm.
you're it's like up there you are passing down good dog to dog. So like that's the inheritance. But I mean, I guess the goody underscore dog part is it just knows that, or
Right? When I said,
oh, you created a new. Okay,
yeah.
okay.
So if I ask goody dog, what kind of thing are you? Oh, you're a good dog. If I ask Riley, what kind of thing are you?
Dog.
You're just a plain old dog.
Right.
So I know that goody dogs have age, and I know this goody dog object has toys. Why do I know? Because it's a good dog.
Right. Right.
But Riley, who's a plain old dog, only knows her age. She does not know toys because dog doesn't have that. If I look at what dog is, all it knows is age, sound, and color. Nothing about toys. But a good dog, that's a kind of dog, plus extra powers, can be asked about its toys. Right? Goody dog has 4 wolf and brown. Goody toys is this. Regular dog, plain old dog, doesn't know nothing about toys. But it does know age, color, and sound. Right? So this idea of data and behavior, we can extend it with inheritance. And as Ruby programmers, we use inheritance from time to time, but we don't use it that much. I bring it up here because when we get to the first framework we're going to do, Rails, we do a lot of inheritance. And so it's important to remember how it works. But as programmers, we don't tend to use it as often as you would think we would use it. Right? The reason why is that it sounds like a good idea. Oh, I know that there are dogs and good dogs and bad dogs and different kinds of dogs. Or, hey, I have customers and I have different kinds of customers. I have corporate customers and individual customers. So maybe I'll have a hierarchy of classes based on the hierarchy of things, kinds of things I have. What we find is it often kind of breaks down
Yeah,
and kind of limits us.
Can we just make that an object?
Mm-hmm. Yeah. And there are other ways of dealing to get all the benefits of inheritance without some of the detractions. So we don't normally cover like, well, what's the downside of inheritance in this class, but there are some downsides of doing things this way. And after you have a little bit more stick time, right, experience with it, you'll start to see what some of those downsides are, and you'll see some ways that Ruby helps us get around those. But you're going to see this inheritance when we get to Rails. So I want you to see what inheritance is and how it works. Right? So the main things to remember from objects, right, and classes. Classes are like the cookie cutters, the factories that make instances of things. And objects are nothing but data and behavior that live together. Right? The dog class has age, color, and sound. Riley has her own age, color, and sound. Roscoe, which is also an instance of dog, has its own age, color, and sound. Right? Two of the same classes, one object has its data, the other object has its data. Right? That lets us change the behavior based on what the data is. Cool? Let's take a break. When we come back, we're going to talk about one other thing from Ruby, and that's the idea of iteration. Right? Enumeration, like you have in JavaScript, where you have for each and loops and map and filter and all that. We're going to talk about how that works in Ruby.